Hello and welcome to the Indian Ocean World podcast. My name is Philip Gooding. For this podcast, I am joined by Dr. Adam Bobbette of the University of Glasgow. Dr. Bobbette is a human geographer and political geologist whose academic career has taken him from Trent and McGill universities to Toronto, Hong Kong, Cambridge, Sydney, and now Glasgow. His research focuses on the history and politics of the geological sciences since the 17th century, philosophies of minerals, planetary theory, and extractivism. Additionally, he is interested in earth knowledges in Southeast Asia and from a global perspective. Today, we'll be discussing his first monograph, which was published in 2023 with Duke University Press. It is entitled The Pulse of the Earth, Political Geology in Java. Dr. Bobbette, thank you so much for joining us and for agreeing to discuss your work. First, I want to ask you, what are the origins of your project? What drew you to Java and the study of volcanoes?
Well, thank you for having me, first of all. That's a complicated question, actually. The origins of the project, in a certain sense, really begin with me in a taxi in central Java and turning a corner in that taxi and seeing the volcano Mount Merapi for the first time at the end of a road, poking up into the sky in a perfect cone, and me wondering, what is that thing? And asking the taxi driver and him saying, that's Mount Merapi. And me asking, what's Mount Merapi? And him saying, it's a volcano. And shortly after that, I learned that more than 1 million people live on that volcano and that it is permanently active. So that was mind-blowing to me at the time. And I had to understand what it meant to live in that kind of place. Why would people live on an active volcano? It sounded just completely counterintuitive to somebody who is from rural Ontario, like what are people doing? And part of the reason that I was interested in that question and interested in trying to understand why people live in an extreme environment like that is actually because I had before that been studying urban flooding in Jakarta. And I was interested in what it meant to live in a city of 20 million people that was sinking while the sea was rising due to climate change. And the kinds of politics that emerged from that, like real radical uncertainty. And I was interested in that question precisely because I'm interested in what it means to live in a changing climate and what it means to live with natural systems that are beginning to behave incredibly unpredictably. So when I was in the taxi and learned about Merapi, that to me seemed like an intensification of that very problem in a way that I couldn't have really imagined. So initially I went to Mount Merapi volcano to think about how to live with climate change. And that was the basis of my PhD and of my PhD field work. But I was also broadly interested in understanding geology. I was conversant with the debates around the Anthropocene. And so when I ended up on Mount Merapi and living there for a year, I had to think about geology because I was suddenly amidst this incredibly vibrant form of geology. And that then, was the seed to what a bunch of years later became the Pulse of the Earth.
Okay, wonderful. So The Pulse of the Earth itself, the book, it borrows its title from a 1942 book by a geologist, Johannes Umgrove. So what is the significance of this book, Umgrove's book, to your thinking? And what drew you to frame your study around the same title?
Yeah, so when I was spending time on Merapi, part of the work that I was doing was trying to understand the history of the science of Mount Merapi. And then that could not be separated from broader questions about the history of the science of volcanoes in Indonesia. And I was trying to understand because I wanted to understand how scientists understood volcanism. Part of my PhD field work was in the scientific observatory at the base of Mount Merapi. So I was following scientists around. I was following volcanologists around like an anthropologist, trying to understand how they understood the volcano and how they made predictions about it and what they thought, the evolutionary history of the volcano was and where volcanoes came from and all these kinds of questions. And part of the way that I go about answering those questions is by looking historically. So that sent me into the archives of the Volcano Observatory, but then also the archives of like the National Volcano Monitoring Organization in Indonesia. And so I was looking at the history of volcanology in that region and how it had changed over time. And one of the people that I came across was this guy, Johannes Umgrove. And he spent some time in Indonesia in the 1920s, fascinated by volcanoes. And the more that I read of Umgrove, the more fascinated and inspired I became by him, actually. Because he he was a kind of scientist that's quite difficult to come across these days. So he was really interested in Hinduism and Buddhism. He conceived of the geological sciences as a kind of cosmological project of like tackling these like big thorny questions of where humans come from and how the earth was formed, what it looked like in its original stages, and how it is that human life is connected to like big geological processes. And he was emphatically poetic and aesthetic in the way that he conceived of science. So for him, so he called doing geology geologizing, and he's not alone in that. Geologists would have said the same thing in the 1920s and 1930s. But the way that he conceived of geologizing was to make these very expansive connections across time and space. So that is, for instance, in his mind, how to connect the diversification of the species with the formation of mountains in Earth's history, and then how that is connected to the rotation of the galaxy in deep time, and etc. So his aesthetic vision was about making these like cosmic connections across these vast scales. And for him, that was an aesthetic project that was driven by also an appreciation of the beauty and complexity of the cosmos that we inhabit. So when I was reading him, he provided a vision of how to do volcano science that was this kind of excessively connective kind of project.
So one of the things that features in your book really prominently is religion. This is obviously shown how this might be inspired in some way by Umgrove's book and his perspective. But I think most readers and people who aren't familiar with the geologists of the 1920s and 1930s would be quite surprised to read a book about political geology that says so much about religion and religion's importance. Could you explain to our listeners the importance of wider social and religious contexts to the genealogies of, I suppose, modern scientific methods, such as volcanology and geology? Perhaps drawing on how, in your book, you talk about this in length, how colonial European geologists were influenced by, for example, ruins of Hindu temples, and also a wider social world that, I suppose, in the colonial circles, disdained Islamic influence in Java.
Yeah, so there's a lot of parts to that question. So let me think about what the best way to unpack that is. I think probably it would be useful if I said a couple of things about what political geology is as a project. And then maybe we can find our way to religion and geology. But if we don't make it there, we'll get there later, I suppose. So, political geology, in the way that I have been practicing it, is really made up of two interrelated moves. The first one is to acknowledge the role of the geological sciences and afterwards what becomes the earth sciences in the histories of European and North American colonialism and imperialism. So the geological sciences, very broadly, cannot be separated from those projects. Those sciences were central to European and North American empires and colonialism. I mean, you just have to think about the significance of geological mapping and the way that it transforms a territory into a resource, right? And that the transformation of that territory into a resource then enables and justifies the exclusion of all sorts of other people from access to those territories. So that's pretty straightforward. But within the history of the geological sciences, that acknowledgement, it's very, very rare. And it's very rare for geologists to unpack how processes of empire and colonialism are connected to the very methods of the science itself. How is it that those political processes are enabled or wrapped up within the epistemologies and ontologies of the science? So, political geology tries to unpack those things. What is it in the way that those sciences come to know the world that also enables a certain kind of politics, that upholds a certain kind of politics? So that's the first move of political geology. The second move of political geology is to realize that the geological sciences are not just a Western invention, they're not just a Western product, but that we live in a world of multiple geological knowledges. Those moves are related because the second one is a kind of antidote to the difficult politics of the first move. So that's why I spend a whole lot of time looking at Javanese conceptions of volcanoes and geological processes and try to acknowledge how those knowledges, in fact, contributed to and shaped and influenced European geologists in their own geologizing. So, to come to the religion question, one of the spaces where Indonesian or Javanese knowledges about geology came to have an influence on European scientists in the late 19th and early 20th century was through religion. And it was through scientists' fascination with Javanese religions, Hinduism, Buddhism, Islam, etc., that ways of thinking about the history of the earth, the structure, the evolutionary structure, the evolutionary history of volcanoes, things like that. One of the ways that Javanese ideas about those things ends up influencing how European scientists think is through this interest in religion. And there's much more to be said about that, about how that actually happens empirically, and we can go on to talk about that. But I want to finish up by saying a final thing, which is that I was really inspired by the work of Martin Rudwig, who's a historian of the geological sciences, and he's a kind of key figure in the field, really incredible scholar. And one of the arguments that he made throughout his career was against the very prevalent idea that the modern sciences are a product of secularization. And the geological sciences specifically don't emerge in Europe and North America through some kind of radical break with religion. that they, in fact, perpetuate, they carry over, they carry forward all sorts of religious preoccupations and techniques, the very techniques of religious scholasticism, enter into the sciences through the geological sciences, such as the way that the history of the Earth is dated, the chronological systems, all sorts of things. So I sort of carry that forward in understanding that the modern Western geological sciences are not a secular project, but that in fact they continue a religious project, a cosmological project in all sorts of ways, such as this very foundational preoccupation with origin stories of the Earth itself. And when geologists are speculating about how is it that the first proto-continent emerges from a world of oceans, this is a fundamentally cosmological kinds of question that they're being preoccupied with that has its precedence within religious tradition.
That is absolutely fascinating. Thank you so much for prefacing your response to my quite winding question with this discussion of political geology, and situating your answer with that. It's absolutely fascinating. Well, then it makes logical sense then to follow that question. Considering we start with the pulse of the Earth question, we've done the political geology question. Let's move on to the final part of the title of your book, which is Java. What is it about Java, politically, geologically, socially, historically, that makes it so central to the pulse of the Earth, to political geology?
Because of the volcanoes. Because there's volcanoes everywhere. I'm not making it up. It's
No.
it's a volcanic island. It has the largest concentrations of active volcanoes in one place than anywhere else on Earth. So you have then a culture which has for millennia lived with this incredibly vibrant form of geology. And then you have a colonial condition, particularly after the eruption of Krakatoa. The colonial response is to try to understand how these damn volcanoes work. This was really because Krakatoa put a kind of a stop to all trade between the colony and the Netherlands. So all the boats carrying stuff back and forth, they were not sailing anymore. And suddenly the economy of the Netherlands was potentially going to bottom out. So they realized that they really needed to try to figure out how these volcanoes work in order to either prevent them perhaps from erupting or to figure out some kind of measure to deal with this volatile landscape. And that moment really becomes the foundation to what we would recognize as a form of modern volcano science. And what happens is that they begin to undertake, surveys of volcanoes for the very first time. They begin to set up observatories to monitor the volcanoes for the very first time. And you have dedicated state employees out working in the territory to try to get some kind of handle on what these volcanoes are doing and how they might predict them. And because of that, they are, of course, engaging with Javanese people and Javanese cultures and societies who've been living with these volcanoes, as I said, for millennia. And there begins to be all sorts of exchanges. And one of the things that I learned in working on that project, and that was really surprising to me and really pushed against the typical narrative, which is that, colonial knowledges were sort of imposed upon Indonesian folks, Javanese folks in specific, and that Javanese people didn't have a kind of voice in the colonial situation, in particular, like around the sciences and stuff like that. This, in fact, wasn't the case at all. These scientists in the late 19th century through to the early 20th century were utterly fascinated by how it was that Javanese people thought about volcanoes. And all sorts of really incredible things happened. Like, for instance, the first scientific observatories that were established on the top of volcanoes, they were established there because the only route to the top of volcanoes was along these ritual procession pathways. Because as you could imagine, nobody lives at the top of volcanoes because they're super dangerous, and you can't grow anything there. The vegetation line is only reaches a certain level. But if you really want to observe what's happening in a crater, you need to be up quite high so that you can see it. And the only people who would be going up that high were people who were undertaking ritual processions to give offerings to deities inside the volcano. So that's where scientists established their first observatories. And of course, it was Javanese people who carried their instruments up there, who built the observatories for them. But Javanese people also told the scientists, what was up there. If they would see a ritual site, Javanese people would explain to the scientists that this was the ritual that was happening. It was for these deities in this volcano, and these deities did such and such in the landscape and connected to other parts of the landscape. And so the scientists knew about the spiritual geographies of volcanoes in Java. And they didn't just dismiss them. The evidence for this is in the writings of the scientists. If you read scientific papers by people like Kemmerling and Van Bemmelen and all these Dutch volcanologists writing in the 1920s, you read their scientific papers, and they will say, I took an old ritual pathway up to the top of the volcano, and I know this because my porter told me that there were these deities in the volcano, and they did this and this and this. So there's a lot of exchange that is happening between these two seemingly different worlds. And the exchange is influencing how it is that Dutch scientists, Dutch geologists are coming to think about volcano processes and volcanic evolution. So to circle back to the question of why Java, it's precisely that. It's the porosity between these knowledge systems. It's the way in which Javanese knowledges about volcanism influenced Europeans. And also, it's the way that Europeans later, after the 1930s, into the 1940s and 50s, erased the significance of Javanese people upon them. So you can see, if we circle back to the definition of political geology and the way that I am practicing it, it's to recognize the role of the geological sciences in European colonialism and empire, to also recognize that it's not just Europeans who practice these knowledges, but that other people do, in this case, the Javanese, and that the Javanese actually influenced how Europeans came to understand volcanic processes.
And that is such an important statement to make and an important history to detail. And you've mentioned already that modern geological sciences have done little, or generally have been quite bad at acknowledging like this kind of genealogy. I wondered, is there a wider praxis that you hope that develops from this? Is there a way modern geologists can acknowledge local social, cosmological, and political contexts within which their knowledges have emerged? Is there something that you would like to see happen moving forwards?
Yeah, absolutely. So I present on this work to geologists and earth scientists. I'm in a school of geographical and earth sciences. So earth scientists are my colleagues. They're across the hallway from me. and I collaborate with earth scientists in all sorts of different ways. Um, so I think that a small consequence of this kind of work could be in the way that we teach the history of the geological and earth sciences. For instance, you would never see an acknowledgement of the significance of Javanese knowledge systems in the development of the history of plate tectonics, for instance, being taught in a first year geology course or earth sciences course. And I know that for a fact because I know how they teach it here. And the curriculum is broadly the same across the board. So I guess I should clarify a little bit that I didn't quite unpack how it was that Javanese knowledge systems shaped the theory of plate tectonics, but that's one of the key arguments of the book. And there's a lot to really go into to show how that happened. But it's really, really important point to make because the theory of plate tectonics is the kind of standard orthodox theory of the evolutionary structure of the Earth. And the way that the story is told about the history of the theory of plate tectonics is that it is focused entirely on European and American scientists who claimed that they had sort of undergone a kind of science that they created a scientific revolution in the 1960s and 1970s when they created the theory of plate tectonics. When they did that, they very conveniently erased the significance of Javanese people who I had alluded to earlier in the story of volcanologists going up precession paths and stuff like that, and learning knowledge systems from Javanese people, because what happened at that moment was that Javanese people taught European scientists to begin making connections between volcanoes on land and what was happening in the oceans, really for the first time. So if we were to teach the history of the theory of plate tectonics, which you would come across in every first year earth sciences class, acknowledge the significance of Indonesian and Javanese knowledge systems in that theory, that would be completely transformative about how young earth scientists understand who shaped their own discipline. And it would make a difference, for instance, when you have European and North American volcano scientists going to Indonesia now to work with volcanologists in Indonesia on, mitigation issues or to do science and things like that. If they had the understanding that they were in fact going to a kind of holy land from which their own discipline owed profound debts, it would change the perception of what it means to be a scientist in that place, which I don't think would be some small thing.
That'd be a huge change. And yeah, thank you for detailing that. And I hope it comes to pass. I'm going to close then discuss in terms of discussions on your book about kind of your experiences that led to its creation. And it's a wonderful book, and it's a kind of a triumph of interdisciplinary history that incorporates geology, anthropology, as you mentioned, volcanology, obviously, history of science, and it's wonderful. And I want to close by asking more about your personal recollections of your fieldwork, which really influenced kind of the narrative structure of your final chapter. Could you tell us more about those experiences? How did they shape the history you've written, notably that which links volcanology and geology to wider socio-political contexts?
So I was really challenged by my friends on Mount Merapi who really asked me to think in a profoundly different way about geology, geological material, the stuff of geology. And that came about because, I would have friends who would say that their, ancestors were inside the volcano, or that there were spirits in stones, or that the like protrusions in certain parts of the volcano were the uh, burial place of like certain Islamic saints who were
Hmm.
also anti-colonial revolutionaries in the 18th century and stuff like that. So that the morphology of the volcano was in fact ancestral. And that to me, so a, a typical or one way that one could um, try to make sense of these claims is to say that they are worldviews,
Hmm.
um, and that they are traditions that are, specific to this place. Um, and that is a kind of way of not really taking those claims seriously. Um, because if we call things worldviews, then we can also kind of dismiss them. We can say that, well, they're worldviews, so what we need to do then is like tolerate them. But I was really sort of challenged to think about what it means to say that geology is ancestral, uh,
Yep.
what it means that for a lot of people, there's a reciprocal relationship between society and geological material in Central Java.
Hmm.
That's why people give offerings, because they have debts that they have to pay to deities that live in volcanoes and on the slopes and stuff like that. So the idea was that society was profoundly, fundamentally geological, that society could only function through this kind of reciprocal relationship with geology. And so that to me was a kind of vision of actually how to live in the Anthropocene, partly because it challenges especially modernist assumptions that geological material is dead and therefore can be extracted and circulated. It, in fact, then demands of us to think about a kind of a more equal relationship with geological material. And I think that that's like profoundly difficult to try to come to terms with, but also deeply, deeply productive.
Yeah, wonderful. Thank you for that. Then final question, just to wrap up. What are you working on now? What's next for your kind of publications? Yeah, what can we look forward to reading or hearing from you in the relatively near future?
Yeah, so I'm working on a book tentatively titled Earthworks, and it's about critical minerals. So your listeners probably know that critical minerals are a kind of collection of different minerals which are really important to technological production. Right now, the many of the minerals which are on like official state government critical minerals lists are minerals which are really essential to the energy transition. So lithium, cobalt, rare earths, all that kind of stuff. And there's a kind of slew of books that are coming out about critical minerals at the moment. And I am trying to think about what what a new kind of philosophy of minerals would be. And I'm trying to weave together biography and history and some field work that I've done in tin mines in just off of Sumatra on Bangka Island, and nickel mines in Sulawesi, and some work in Austria and Norway, different mines, cobalt mines and stuff like that. So that's what's taking my time these days.
It sounds absolutely fascinating. And again, as with your previous book, which you've discussed today, incredibly urgent and important work. So thank you very much for giving us that preview and for discussing the pulse of the Earth with us. Also want to thank, before closing, Sam Glee-Riemann for organizing and producing this podcast. And of course, I want to thank you, the listener, for streaming or downloading. Once again, my name is Philip Gooding, and this is the Indian Ocean World podcast.
We would like to acknowledge the generous support of the Social Sciences and Humanities Research Council of Canada. The Indian Ocean World podcast is produced under the SSHRC-funded partnership Appraising Risk Past and Present. The podcast runs in conjunction with the annual speaker series at the Indian Ocean World Centre at McGill, University, Montreal.